We've got an airplane problem, so we're going to solve this with vectors. Remember that airspeed plus wind speed equals ground speed. So airspeed, 750 miles per hour at a bearing of north 40 degrees east. So as you graph that one out, northeast, north and east, 40 degrees is that angle between north and east. So when we change this to standard position, which we have to do with every one of these angles, standard position starts here, measures counterclockwise, so that's 50 degrees. Cosine 50, comma sine 50. The wind is 30 miles per hour, so airspeed plus wind speed. Wind is 30. We still need to get the angle and everything here. And the wind is blowing from the southeast. Directly southeast means that it's a 45-degree angle. So as we graph this out, 45-degree angle from the southeast, north, south, east. So it's blowing from this direction to the northwest. And it's a 45-degree angle, like we said. So standard position is going to be 90 plus 45 is 135. Since it's from the southeast, it's blowing toward the northwest. So to get our vector, our resulting vector, we're going to add these. So we're going to do 750 cosine 50 plus 30 cosine 135. As always, make sure you're in the correct setting, degrees for this one, because those are in degrees. $750 cosine 50 plus 30 cosine 135. And we're going to store that so we have it for later. .878. Do the same thing with the y coordinates. 750 sine 50 plus 30 sine 135. Store B, so we have it for later. $747. So there's our resulting vector. Now, it makes sense. The plane was flying northeast. It makes sense that this vector is going to the right and up, which would also be northeast. In order to get our speed, we do speed equals the square root of a squared plus b squared. And we save those as a and b. So a squared, any parentheses around it though. A squared plus b squared .208 miles per hour. That's your speed. And then we're going to find the angle. We're going to find it first in standard position by doing b over a. Tangent equals b over a, which means we do arctan to solve it. B over a So our standard position angle is 52 degrees. 52.3, we'll just round to the nearest tenth. So standard position angle is 52.3. So this right here is 52.3. That's not how you measure our direction angles. That is the correct quadrant, though, because this is going right and up, which is quadrant 1. So we're in the right quadrant. We don't have to add or subtract any angles from it. But when you write your direction angle, we measure from north, which means we need the complementary angle right here. So 90 minus 52.3, 37.7. So that's how we measure it from north. 37.7 degrees towards the east. And we had our speed up here.